of the reaction equals negative Q of the reaction equals negative open parenthesis MCAT. You need that. But the other thing you need is the other experimental setup we do, which is to find the specific heat of something. And to do that, we heat that something up. In this case, it's a sample, a rock, a metal, it's usually metal. We heat it up really hot, and then we put it into water that we know the temperature of, and the heat is transferred out to the water, and we measure that temperature change, and then we know how much heat that rock was capable of holding. It's still calorimetry, but it looks like this. The heat that the sample lost is equal to the heat that the water gained. So one side needs to be negative, and I promise you, it doesn't actually matter what side you put that negative sign on, as long as you do your math correctly. So these are our two things, equations, that we need to know for the final and the last quiz for chapter 9. This is it. All right, so this one's a pain in the ass because Q still equals MCAT, and I need to expand it way out. So I'm going to expand this Q, mass of sample, times specific heat of sample, whatever it is. That's usually what you're trying to find. This is what you'll do next semester. You'll find the specific heat, I think, of 3 metals. Times, here's what's confusing. Oh, this whole thing's negative, so I'm going to use brackets. If I got to use parenthesis inside, I need to use brackets outside with a negative outside. So temperature final minus temperature initial, and here's the confusing part. The temperature final is the final temperature of the whole system, the sample and the water. So temperature final is the same number on both sides. The temperature initial is the initial temperature of the rock, which is probably super high. And then over here, we're the same thing. But this time, it's the mass of the water times specific heat of water, we know that number, 4.184, times the final temperature of the system minus the initial temperature of the water. Okay, let's plug our numbers in. All right, so we've got a 57-gram sample of glass, that goes here, times the thing it wants us to find. It wants us to find the specific heat capacity of the sample. So we put it in a calorimeter, and we have 150 grams of water, that's over here. Dot, basic figs. The glass sample starts off at 98.6 degrees Celsius. That's the super high temperature, that's the initial temperature of the sample. So that's 98.6. And all of this is negative. And we're going to have a final temperature here. Temperature of the water is 20 degrees Celsius. That's the initial temperature over here. When the temperature of the water stops changing, it's 24.7. So the water heated up. And that is our final temperature of the system on both sides. Like this. Okay, we're ready to solve. I'm going to show you how I put this in my calculator. The pressure remains constant at 1 atm. That's cool. All right, so I'm doing this first. 24.7 minus 20. 24.7 minus 20. Enter. And of course, I have a multi-view calculator, so all my numbers just stay with me. I don't got to write anything down or whatever. I can see everything that's going on. I'm going to multiply it by the specific heat capacity. I'm going to multiply it by 150. And now I have this whole side over here. I don't need to write it down, but I'm going to, because you can't see my calculator very well. This unit's joules, because the grams canceled out and the degrees Celsius canceled out. Now I'm going to do this, 24.7 minus 98.6. And then I'm going to multiply it by 57, right? All of these things are being multiplied by each other. So times 57. So then I have it's negative, -4212.3 times C, but the whole thing is negative, because that guy, this is what made it negative. And then to find C, I'm gonna divide by this value. So, because my calculator's awesome, I'm gonna go up and grab that number, and then press divide, and now go up and grab that number. I don't have to re-enter anything into my calculator, and this is 0.70 joule over gram degrees Celsius. You will have to do that on the final. This is called specific heat of a metal question, if you wanted to look it up on YouTube. So you'll have to do what we did in virtual lab for calorimetry, mixing an acid and base together and telling me something about it, and you'll have to do specific heat of a metal. That's the two questions that'll be on the final. Okay,